Hello everyone, I'm Radhika from Wild One TechSoft. Imagine you have a large-scale production system that is running either locally or on the cloud. How can you be sure that it will survive the network crashes or pod restarts or resource exhaustion? Chaos engineering is the answer. Well, what does this mean? Chaos engineering is intentionally injecting controlled failures into the system so that we can uncover the weaknesses well before the actual user experiences them. So instead of being reactive and waiting for the outages to occur, engineers can simulate them proactively. The modern cloud native applications, especially the ones that use Kubernetes, have their application running inside pods, which are basically small deployable units that contain containers, dependencies, and resource configurations. And these pods become the ideal targets for injecting faults. Now, we have adversarial agents in the chaos engineering tool, which help to create realistic failure scenarios like CPU exhaustion or network latency or pod restarts and input-output throttling. And the goal is to observe how the system behaves when such pressure or stress occurs. Now, at the core of the architecture, we have the chaos orchestrator, which is basically the brain of the system. And what it does is it collects telemetry using monitoring tools, it observes the system health, and then it intelligently decides which failure scenario or the individual test is to be conducted next. And once we have an action plan ready, we execute these failure scenarios, and thus an autonomous feedback loop is created. How does this really matter? Well, modern distributed systems are incredibly complex, and the traditional testing methods often miss the realistic failure conditions. So chaos engineering is something that can help to identify bottlenecks, reliability issues, or recovery issues well before they become an actual production incident. So in short, chaos engineering is not just about breaking the system, but rather it's about building resilient systems that can survive the uncertainty in the real world.